Hello, now I will start my presentation for EL6562 Image Processing in Computer Visions. The topic of my project is Design and Evaluation of Object Tracking. This project is to design and evaluate kernel-based object tracking using templates and density-based appearance models. In this project, it first introduces an overview of three different approaches of object tracking, especially the kernel tracking. Secondly, it introduced basic theories of templates and density-based kernel tracking using mean-shift method. Then it uses MATLAB to simulate object tracking process, analyze the results, and make evaluations. And finally, it draws a conclusion on this project and gives advice for future improvement. The aim of object tracking is to estimate the trajectory of an object by locating its position when it moves in a scene, which can be considered as frames of a video. There are different kinds of algorithms that can be applied in object tracking, such as kernel-based tracking, feature-based tracking, and silhouette-based tracking. I will talk more about it in the future. About the kernel tracking, it has two different models. One is called template and density-based appearance model, and the other one is called multi-view appearance model. Note that the template-based and density-based appearance model have three different algorithms. One is the mean shift, which is the focus of this project, and the other two are KLT and layering. I will talk more about it in the future. Now I will talk about the mean shift algorithm. The object tracking based on mean shift algorithm uses statistical histogram to make a model of desired figure region. The histogram approximately indicates the probability density function of distribution analysis in the corresponding figure region. We can get the used covariance of the histogram of the target model by equation 1 and 2. And assume that the center of the object is at the position x0, then the object can be described as equation 3, and the object at position y can be described as equation 4. And finally, we can get the result by equation 5. This algorithm has many advantages. First, it is very efficient to calculate. And second, it is easy to accomplish using blocks, which is very convenient to combine with filtering and data correlation method. And finally, it can be widely applied in various areas and get good results in image processing and computer vision. Now I will show the simulation and evaluation result by MATLAB. The first part is object-based multimedia system. First, perform pixel-by-pixel frame differencing using the first frame of the image sequence as reference frame. The figure 3 shows the results of 3 non-consecutive resulting frames and the corresponding original frames. Second, apply different classification threshold to the results above in order to obtain a binary image. The figure 4 shows the results of 3 binary images of 2 different threshold values. The first one, the threshold value is 0.1, and the second one is 0.3. Thirdly, use block-based frame differencing with different block size. The first one is the original frames, and the second one is the block size 2 times 2. And the last one, the block size is 8 times 8. And finally, given a frame ft with moving objects, find the position of the same objects in frame ft plus 1 using the extracted features. The figure 6 is the result of 6 non-consecutive frames. The part 2 is the result of mean shift object tracking. I will use MATLAB to show the results. In this part, I will implement single object tracking using mean shift method. I will use 3 video samples to run the program and compare them with each other. The first video is the one used in part A, which is a traffic video, and the second one is a flash, which expresses the movement of 3 balls, and the third one is a self-recorded video using my iPhone. Now we'll look at the first one. First, we should select our target. We'll use the white car to track. Now we'll see the result. This is the result of the traffic video. According to the result, we can see that it can mostly track the moving vehicle successfully, except the final part. This is because when the vehicle goes further, it becomes smaller in the 2-dimensional picture and finally exceeded the limitation size that this program can successfully track the object. Therefore, if the object is accurate and large enough, it can accomplish object tracking successfully, while if the object is too small, it cannot track as before. Now we'll look at the second video. We have to first change the path. Now let's run the program. We'll choose one of the 3 balls. Let us choose the middle one. And let's look at the results. From the result, we can see that it can successfully track the moving ball when its speed is not so fast. However, when the speed becomes faster, it will lose the target and fail to track the moving object. Now let's look at the last one. The last one is a .mov file rather than the .avi file. Let's run the program. Let's track the face of the dog. Because this video is a .mov file, it will take more time to process it. And during this time, let us see the details about object tracking. The point tracking is to use one or more points to represent an object, and the association of each point is related to each previous statement, which contains the object position and its movement. It can be shown in the figure 2a. And the kernel tracking is to track an object by its shape and appearance. For example, in this project, I use a rectangular shape to represent the tracking object. By using this approach, we track an object by computing how the kernel changes the position from one frame to the next. And silhouette tracking is to use an accurate shape to represent an object, since sometimes we cannot use a simple geometric shape such as a rectangular to represent the object. It tracks an object by finding the object region according to the model generated by previous frame. And this is how kernel tracking consists of. The template and density-based appearance models are widely applied in object tracking because they are simple and have low calculation cost. When tracking a single object, we can first estimate the position of the object at frame t-1, and then we can estimate the initial position and frame t based on previous information. After this, we continuously update the position using mean-shift iteration until we get the maximum similarity. For the multi-view appearance models, they used eigenvectors to compute the transformation of current image to the reconstructed image. The eigenspace is a very efficient method to calculate similarity instead of standard template matching techniques, because the eigenspace-based similarity computation is equivalent to matching with a linear combination of eigentemplates. Okay, let's come back to the program. There are several ways to further improve this project. First, when I use mean-shift algorithm to accomplish object tracking, it takes a very long time to successfully track the dog's face in the self-recorded video. This is because it is a .mov file rather than .avi file. Therefore, we can modify the file reader code in order to reduce the processing time. And second, although the program is successful to track objects when the moving speed and the object size are within limitations, but it is not that efficient when there is a sudden increase in the speed of the object, or the size of the object is too small to track due to the position change in frames. Therefore, we can further increase the accuracy and tolerance in order to track objects more precisely. And finally, due to the time limitation, I can only achieve the goal in the command window of MATLAB. It would be more user-friendly if a GUI is designed, which can also be manipulated more efficiently. Now, please be patient to the progress of this tracking. It is almost done, so please be patient. Okay, now let's look at the result. Okay, that is the result of the self-recorded video. From the result, we can see that it can successfully track the position change of the dog's face, but it requires more processing time to accomplish the object tracking, which should be improved. Okay, that's all of my presentation for this project. Thank you for watching.